Good morning, everyone. In today's discussion on electrical measurement, we will talk about units, characteristics, and calibration. The agendas of for discussion are units of measurement, standards of measurement, dimensions of measurement, instrument performance criteria or characteristics, calibration of instrument, traceability of instrument. Starting with units of measurement, metrology is the science of developing nationally and internationally accepted units of measurement. A unit is any standard used for making comparisons in measurement. Unit conversions allow for measurement of any property or properties that have been recorded using different units. The metric system is the framework of units of measurement that has grown from its 1874 birth in a diplomatic treaty to the more modern General Conference of Weights and Measures. The modern system is properly called International Systems of Units or SI, an abbreviation for the French word La Système International de Units. Today, most people use the names metric and SI interchangeably. The metric system is the main system of measurement units used in science. Each unit is considered to be dimensionally independent of the other. These dimensions of measurements are length, mass, time, electric current, temperature, amount of any substance, and luminous intensity. There are basically seven fundamental units. We'll cover the old definitions of these seven fundamental units. Length, expressed in meters in SI unit. The meter is the metric unit of length. It is defined as the length of the path light travels in a vacuum during 1 by 299,792,458 of a second. Second fundamental unit is mass, represented in kilogram. It is the mass of the international prototype of the kilogram, a standard platinum iridium 1 kg mass housed near Paris at the International Bureau of Weights and Measures. Third is time. The basic unit of time is the second. The second is defined as the duration of 9192,631,770 oscillations of radiation corresponding to the transition between two hyperfine levels of Ca-133. The fourth unit is temperature. The Kelvin is the unit of thermodynamic temperature. It is the fraction of 1 by 273.16 of the thermodynamic temperature of the triple point of water. The Kelvin scale is an absolute scale, so there is no degree. The triple point is the temperature and pressure at which solid, liquid, and vapor phases of a particular substance coexist in equilibrium. The fifth fundamental unit is amount of a substance. The mole is defined as the amount of a substance that contains as many entities as there are atoms in 0.012 kilograms of carbon-12. When the mole unit is used, the entities must be specified. For example, the entities may be atoms, molecules, ions, electrons, cows, houses, or anything else. The sixth unit is luminous intensity. The unit of luminous intensity or light is the candela. The candela is the luminous intensity in a given direction of a source emitting monochromatic radiation of frequency 540 into 10 raised to 12 Hz with radiant intensity in the direction of 1 by 683 watt per star radian. And finally, electric current. The basic unit of electric current is the ampere. The ampere is defined as the constant current that is maintained if two infinitely long straight parallel conductors with a negligible circular cross section placed 1 meter apart in vacuum would produce a force between the conductors that is equal to 2 into 10 raised to minus 7 Newton per meter of length. In the redefinition in May 2019, four of these seven SI units, the kilogram, ampere, Kelvin, and mole, were redefined by setting exact numerical values for the Planck's constant H, elementary charge constant E, Boltzmann's constant K, and the Avogadro's constant N, respectively. The second, meter, and candela were already defined by physical constants and were not subject to corrections to their definitions. In the redefinition in May 2019, four of the seven SI units, the kilogram, ampere, Kelvin, and mole, were redefined by setting exact numerical values for the Planck's constant H, elementary charge constant E, Boltzmann's constant K, and the Avogadro's constant N, respectively. The second, meter, and candela were already defined by physical constants and were not subject to corrections to their definitions. The new definitions are aimed to improve the SI units without changing the value of any of the units, ensuring continuity of the existing measurements. The figure below shows the interdependence of each of these seven universal constants with the seven fundamental measurement units. The seven fundamental units of measurement were defined based on the seven universal constants, which are Planck constant denoted by small h, elementary charge constant denoted by small e, Boltzmann's constant denoted by k, Avogadro constant denoted by n, speed of light denoted by small c, luminous efficacy denoted by capital K, and the ground state hyperfine structure transition energy denoted by del nu Cs. Other than the basic fundamental units, there are a few other units of measurement that we come across in our day-to-day life. They are liter. While the metric unit of volume is the cubic meter, the most commonly used unit is the liter. A liter is equal in volume to 1 cubic decimeter or meter cube, which is a cube that is 0.1 meter on each side. Armstrong. 1 Armstrong unit equals 10 raised to minus 8 centimeter or 10 raised to minus 10 meter. Named after Andreas Jonas Armstrong, the unit is used to measure the chemical bond length and the electromagnetic radiation wavelength. Third, cubic centimeter. A cubic centimeter is a common unit used to measure solid volume. The corresponding unit of liquid volume is the milliliter, which is equal to 1 cubic centimeter. Other than the 7 fundamental units, there exist 12 derived units, which are radian, unit used to quantify an angle, hertz, unit for frequency, newton, unit of weight or force, joule, unit of energy, heat or work done, watt, unit of power or radiant flux, coulomb, unit of electric charge, volt, unit of electric potential or voltage, farad, unit of capacitance, tesla, metric unit of magnetic flux density, degree Celsius, temperature relative to 273.15 Kelvin, and Gray, unit of absorbed radiation dose. Now that we have discussed the basic 7 fundamental units and the 12 derived units, let's talk about systems of units. A system of units is a set of related units that are used for calculations. The system includes base units, which represent base dimensions, and derived units, which represent products of powers of 2 base dimensions or more. There are basically 8 systems of units. They are SI system, FPS system, MK system, CGS, EMU, ESU systems, atomic system, and MTS system. In metrology, the science of measurement, a standard or etalon is an object, system, or experiment that bears a defined relationship to a unit of measurement or a physical quantity. Standards are the fundamental reference for a system of weights and measures against which all other measuring devices are compared. There is a 3-level hierarchy for the standards. Primary standards, made to the highest metallurgical quality and have a well-defined definition. Secondary standards are very close approximations of the primary reference standards. And thirdly, the working standards that are used in industries that have a traceable relationship to the secondary and the primary standards, and they deteriorate over time. Dimensions of a physical quantity are the powers to which the fundamental quantities must be raised to represent the given physical quantity. In mechanics, all physical quantities can be expressed in terms of mass, length, and time. Dimensional measurement is how we know and quantify the size and shape of things. It involves lengths and angles, as well as geometrical properties such as flatness and straightness. Dimensional measurement is of fundamental importance for interchangeability and global trade. It is how we ensure that things will fit together. Without global length standards as the basis for standardized parts, global industry would not be possible. Instrument characteristics allow users to select the most suitable instrument for any specific measuring job. There are two basic performance criteria of measuring instruments: the static criteria, value of the measured variable that changes slowly, and dynamic criteria, value of the measured variable that changes very fast. The static criteria and parameters of measuring instruments describe the performance of the instruments related to the steady-state input-output variable only. The various static characteristics and parameters are distinct for quantitative description of the instrument, while the dynamic criteria shows the time response behavior of the instrument to the changing in the magnitude of interest by observing the signal output with time. Principally, there are 16 static criteria: accuracy, that measures closeness of a measurement of any true value; precision, closeness of agreement among a set of results; sensitivity, increment of the output signal to the increment of the input measured signal; repeatability, variation in measurements taken on the same time under the same conditions; reproducibility, ability of a measurement to be duplicated either by the same person or by someone else under changed conditions; drift, change in instrument output over time when the true value is constant; resolution, minimum change in input that is required for change in output; threshold, the minimum limit of the input reading. Range, the input range of a measuring device specified by the minimum and the maximum values of the input variable. Span, difference between the maximum and the minimum values of the input variables. Linearity, maximum deviation from linear relationship between the input and the output. Error, deviation of the true value from the desired value. Hysteresis, when uploading applied input do not create the same output. Creep, time an instrument needs to adapt to changes in applied input. Trueness, closeness to the mean of a set of measurement results to the actual true value. And calibration. There are four dynamic criteria. Those are speed of response, dynamic error, that is the difference between the true and the measured value with no static error; lag, that is response delay; and fidelity, the degree to which an instrument indicates the changes in the measured variable without dynamic error or faithful reproduction. Here in this picture we see the classification of the performance criteria of an instrument. They are broadly classified into four categories: static criteria, dynamic criteria, static error, and dynamic response. Under the static criteria, they can be accuracy, precision, repeatability, reproducibility, hysteresis, threshold, resolution, stability, tolerance, linearity, sensitivity, range, calibration, and under drift it can be zero, span, or zonal. The dynamic criteria are dynamic error, fidelity, measuring lag, and speed of response. Static errors can be mistakes, systematic error, random error, and gross error, while the dynamic response can be zero order instrument, first order instrument, and second order instrument. Calibration is a comparison between a known measurement, the standard, and the measurement carried out using another instrument. Calibration is the way that standards are transferred from one country to another and from one instrument to another. The primary reference standard for the SI units of measurement are held in France, and each country compares their national standards against these. Calibration of measuring instruments has three objectives: checking for the accuracy of the instrument, determining the traceability of the measurement, and finally repairing of the device if it is out of calibration. Measurement traceability is used to refer to an unbroken chain of comparisons relating to an instrument's measurements to a known standard. Traceability of instruments is used to determine its bias, accuracy, and precision. A traceable measurement is one which has an unbroken chain of calibrations going back to the primary reference standard with uncertainties calculated for each calibration. For more enthusiastic students, these are the reference links from where they can know more about the subject.